The Haas control panel provides the interface between human operator and automated machine. The panel features a well-planned design, and the layout has remained nearly identical across all Haas machines from the very first one manufactured in 1988 to modern machines available today. Let's review the lesson objectives. By the end of this video, students will be able to name and identify the 9 major groups of keys on the Haas control panel. Identify the parent groups of commonly used keys. Understand the function of the 6 operational modes. Locate frequently used keys within operational mode subgroups, and develop a basic understanding of each key on the control panel. Before taking an in-depth look into the control panel, it's important to clarify our expectations for this video. The Haas control is simple to use but powerful in capability, and to explore every detail of its function requires a reference manual several hundred pages in length. Students will not become absolute experts just by watching this video. However, they will gain a basic understanding of the control functions and key locations, with a few helpful details along the way. It's recommended that students refer back to this video and watch it again as needed using the timeline to rewind to build their knowledge and understanding. Let's begin by taking a look at the control panel as a whole. While at first look the number of buttons can be intimidating, by learning the organizational groupings, users can quickly become familiar with where functions are located. The control panel can be divided into 9 major groups: reset keys, display mode keys, operation mode keys, numeric keys, alpha keys, cursor keys, overrides, jog keys, and function keys. To build our understanding of each control key group, let's take a closer look at each, beginning with the reset keys. Group 1 is the reset keys. The orange or red colored wider reset key is used to cancel and stop running programs mid-operation. It is also used to clear active alarm messages and to move the cursor back to the top of the program in certain operational modes. The blue power-up restart key is used to home and zero the machine's axes after powering on before running any programs. The recover or restore key is less frequently used and accesses a step-by-step recovery process in the event that a tool change operation becomes interrupted by a crash, jam, or malfunction. Group 2 is the display mode keys. These keys are used to change what is shown on the machine's LCD panel and to access various displays. Let's go through the 8 display mode keys one at a time from left to right, starting with the top row. The program key is used to display the active program while in edit, memory, or MDI modes. We'll discuss those modes in a few minutes. The program key may be used to access the intuitive programming system, which is an available control option. Most programs are run as G-code posted from CAM software and do not require the operator to frequently use the program key. The key labeled POSIT stands for position and is frequently used to cycle through the 4 coordinate systems the machine is capable of displaying. These 4 systems are machine coordinates, work coordinates, distance to go, and operator coordinates. The next key is called offset and is used to display the tool and work offset tables. Note, as this is a display key, pressing this key does not actually set the offsets. Pressing the key multiple times will toggle between display panels, making either the tool offsets or the work offsets the active panel. On newer Haas control software, the active panel is designated by a white-colored background, while the rest of the display panels have a blue-colored background. Rounding out the top row of the display key group is the current commands key. This key is used to display the active G and M codes running in the machine's memory, as well as additional information such as timers and counters. While viewing the current commands display, the operator can access additional displays by pressing the page down key in the cursor keys group, which we'll discuss in a few minutes. One of the most useful and most frequently accessed pages of the current commands display is the position display page, which shows coordinates in larger text and can be viewed by pressing page down 3 or 4 times after pressing the current commands key. Now let's take a look at the bottom row of the display group keys. The alarm messages key is used to display a log of any alarms the machine has encountered. Alarms may be caused by improperly formatted code, commands that cannot be executed, or by machine faults. Most alarms are represented by 3-digit codes, which can be referenced in more detail by looking them up online or in a manual. The parameter and diagnostics key is a dual-function key. One press enters the parameters display, while a second press enters the diagnostics display. These two displays are used only for service and troubleshooting. Machine parameters should be altered only by trained service personnel and should never be changed, tampered with, or adjusted by the machine operator. To reiterate, the parameter diagnostic key is not frequently accessed during normal operation of the machine. The setting graph key is also a dual-function key. One press will access the machine's user-selectable settings. A second press will access the machine's graphics mode, used for verifying and simulating toolpaths and code. The machine settings are numerous, but are grouped by category tabs, and each is referenced by a 1 to 3-digit number. The settings are not changed or accessed often, but are available if the operator needs to change the machine's behavior for purposes such as automatically powering down at the end of a part cycle or turning the screen off after some number of minutes. The graphics display mode is very frequently accessed, typically prior to the first article run of a new program. When in graphics mode, code can be run and verified without any risk of actual machine movement. A simulation of the path of motion generated by the G-code commands is displayed on the screen. The final key is the Help and Calculator key, which is also dual function. One press for the Help menu, 2 presses for the calculators. The Help menu is context sensitive and displays information relative to whatever was on the screen prior to pressing the Help button. Furthermore, it contains a full comprehensive reference of machine operation and programming instructions. The Calc displays features more than just a 4-function calculator and can be used to determine feed rates, angles, and geometric layout dimensions. Certain revisions of the Haas control panel and software may label these keys slightly differently, however they are still used for the same basic purposes. Group 3 contains the operational mode keys and is perhaps the most important of all the key groupings on the Haas control panel. There are 6 operational modes, which are designated by keys shaped to a point on the right-hand side. The 6 operational modes from top to bottom are Edit, Memory, MDI, which stands for Manual Data Input, Handle Jog, Zero Return, and List Program. Generally speaking, the keys located in the rows to the right of each pointed-shaped operational mode key belong to that particular mode. While there are exceptions to every rule, in many cases the mode key must be pressed before the associated keys to the right have any effect. Let's first discuss the basic function of each of the machine's 6 primary operational modes. The Edit mode is used to create, alter, and change NC code programs. After any necessary edits are made, Memory mode is what is used to run programs on the machine's control and orchestrate the machine's movements. Care must be taken when the machine is in memory mode, as it can move quickly and with full automation if the cycle start button were to be pressed. MDI mode, or manual data input mode, is used to run short pieces of G and M code for setup purposes and to command the machine's automatic tool changer. The handle jog mode is used to manually reposition the machine's axes of motion by using the handle jog wheel and associated jog keys, which we'll discuss in a few minutes. The zero return mode is used to take the machine's axes to their home or zero position. Finally, the list programs mode is used to transfer programs between external media such as a USB device and the machine's control. It also is used to select the program to run in the machine's memory. Let's take a look at each key from left to right, starting with the Edit mode. The Insert key is used to place text at the current location of the cursor. The Alter key is used to change existing text. The Delete key is used to remove text. The Undo key is similar to Ctrl-Z on a computer and steps back to the previous state before the immediately prior input. Now let's take a look at the memory mode keys. The single block key is used to run the program one line or one block at a time. Single block is useful during the first run of a program to ensure the code produces the desired result. One press turns it on, and a second press turns it off. The dry run key is used to verify the programmed motions without any material loaded, so the machine essentially will be cutting air. This function is not particularly useful and is rarely ever used. The option stop key is used to tell the machine whether or not to pause when it reaches an M01 command. With the option stop turned on, the machine will stop at an M01 command, such as after a tool change or at a point where the operator needs to check something. By default, option stop is turned off, and when off, M01 commands are simply ignored and the program continues to run. The block delete key is used to selectively ignore code blocks with a preceding / character at the beginning of the line. Programmers will often post NC programs with the / before the M08 coolant on command, so the block delete key can selectively enable or disable coolant throughout the program. That finishes off the memory row keys. Now let's take a look at the MDI row keys. The coolant key is a toggle which turns the coolant on or off. This key is functional at all times, regardless of which operational mode the machine is in. The orient spindle key is used to rotate the spindle to a fixed, known location for special operations such as broaching, and is not typically used in most types of work. The ATC forward and reverse keys are used to activate the automatic tool changer. Simply pressing either key rotates the tool changer one space in the selected direction. Entering a tool number, such as T3, and pressing either key will cause the machine to switch to that particular tool through the shortest direction possible, regardless of which ATC key was pressed. The handle jog row features keys to select 4 different jog speeds or increments. The leftmost key offers the smallest increment or the slowest speed, and the rightmost key offers the largest increment or fastest speed. Faster jog speeds are used to move the machine's axes large distances, while slower jog speeds are used for precision control over smaller distances. All 4 jog keys indicate the increment per tick of the hand wheel in 2 types of units. On the top row of printed numerals are units of inches, and on the bottom row of printed numerals are units of thousandths of an inch. From left to right, the increments increase by a factor of 10 with each key. The leftmost jog key represents the smallest increment and moves 1/10,000th of an inch per tick of the handle jog wheel. The second key over represents a 1/1000th increment. That is, for each tick of the handle jog wheel, the machine's axis will move 0.001 inches. The third key over from the left is the hundredths jog key and results in significantly faster movement of 0.01 inches per tick of the jog wheel. And finally, the fourth jog key over represents the tenths jog key. For each tick of the jog wheel, the machine will move 0.1 inches. This jog increment must be used with caution as the machine moves very quickly, and it's easy for the operator's input to exceed the machine's ability to quickly respond, resulting in a bit of further motion even after the operator stops turning the hand wheel. The tenths jog increment should not be used when the spindle is in close proximity to the table or fixtures, and is often disabled on smaller machines and in school settings. The zero return row features multiple keys that serve very similar functions with some slight differences. The all key takes all 3 axes to their machine 0 positions. The home G28 key takes all 3 axes to their maximum positive extensive travel, which is the same as the machine 0 positions for the X and Y axes, but may be slightly higher on the Z axis on certain machines. The single key can be used to move one axis to its machine 0 location by typing the axis letter first, then pressing the single key. This function is often useful with the Z axis to easily raise the spindle, or with the Y-axis to bring the table close to the machine's doors within reach of the operator. The Home G28 key can also be used to home a single axis, again by simply entering the axis letter before pressing the key. The final remaining key in this row is the origin key. Its function is not related to the others. Although the origin key resides in the zero return row, it's commonly used when in handle jog mode to zero out the operator position coordinates for setup purposes, such as when using an edge finder or dial indicator. The final operational mode row is the List Program row. Pressing the Select Program key will take whatever program the cursor has highlighted and make it the active program in the control's memory. The active program is designated in the program list by an icon resembling the letter A next to the program name. The Send and Receive keys serve different functions on different era machines, but are used to transfer programs to and from the machine's control over an RS-232 serial interface or via a floppy disk on older machines. On newer machines, when loading programs to or from a USB flash drive, it is not necessary to use the Send and Receive keys. The Erase Program key is used to delete programs from the controller's memory or to clear a program entered in the MDI screen. While there are certainly a lot of keys, each with a specific function, it will help to remember that they are organized and grouped by rows, each belonging to their operational mode. However, we should point out that in some instances, certain keys that belong to one mode may be used when in a different mode. For example, the MDI mode is actually classified as a subset of the Edit mode in newer software revisions. That makes sense because editing functions such as Insert, Alter, and Delete can be used within the text window in MDI mode. With practice on the machine or control simulator, you'll build proficiency with remembering and understanding both the location and operation of the various keys in the Group 3 area of the control. Group 4 contains the numeric keys featuring the digits 0 through 9, a negative sign located to the left of the 0 key, a decimal point located to the right of the 0 key, and cancel, space, and enter keys along the bottom row. Special characters such as the asterisk or ampersand are designated in a smaller yellow font and are available by pressing the Shift key in the alpha group prior to pressing the desired numeric key. When entering text to the input line or while working in edit mode, the cancel key functions just like the backspace key on a computer keyboard. The right enter key takes numbers or text from the input line and inserts them to the location of the cursor on the screen. Group 5 contains the alpha keys, with all 26 letters of the alphabet from A to Z arranged alphabetically. Additionally, this section features the previously mentioned Shift key used to access special characters. This section also features parentheses keys and the semicolon key, which is also known as the end-of-block character key. Group 6 features the cursor keys, which are used to navigate through programs and tables on the machine's display. There are 4 cursor arrows: up, down, left, and right. The blue keys in this section include Home at the upper left, which places the cursor at the beginning of the program or at the top of an offset table, and End, which places the cursor at the last line of a program or at the bottom of an offset table. Also in blue are the Page Up and Page Down keys, which are used for navigating lengthy programs and offset tables in fewer key presses. Group 7 is the override keys. Some of these keys are used during setup, and many are used while a program is running. Notice these keys are arranged into 4 rows. Let's take a look at each. The first row of override keys relates to the feed rate. If a feed override is in effect, the 100% feed key quickly returns the machine to feeding at the full rate commanded by the program. To the left of the 100% key is the -10% key, and to the right is the plus 10% key. The hand control feed key uses the handle jog wheel to vary the feed rate in increments of 1%. After an operator is able to observe and listen to a cut at the programmed feed rate, he may use the overrides to slow down the feed if the cutting load is too heavy, or to speed up the feed rate if the tool is performing well and reducing cycle time is a priority. The next row down is arranged in a similar fashion, but is used to override the programmed spindle speed. The third row down features only 3 keys. The fourth position is occupied by a label reading spindle. These 3 keys control the rotation of the spindle, clockwise, stopped, or counterclockwise. On the bottom row are the rapid override keys, offered in 5%, 25%, 50%, and 100%. Rapid motion is the fastest speed a machine can move, and is used with certain G-code commands such as G28 and G00. The Haas mini mill can perform rapid movements at 700 inches per minute, while other machines can exceed 1,000 inches per minute. When running verified and proven programs in production, 100% rapid is used to minimize the time spent traveling through air and reduce cycle times. In an educational setting, or when running a program for the very first time, it's advisable to set the machine to 5% rapids. When set to 5% rapids, the machine moves slow enough that the operator can respond in the event of a problem such as incorrect tool length offsets. There is little to be gained from running at high rapids on the first run of a part. With 50 and 100% rapids, any mistake in commanded position can quickly result in catastrophe, such as a tool breaking or the machine crashing, before the operator even has a chance to respond. These sort of mistakes are very costly, but preventable by making the first run at slower rapids until the program has been proven successful. Group 8 features axis selection keys. These keys are used when the machine control is in handle jog mode. Note the position of each axis key. The X-axis keys are located to the left and right, while the Z-axis keys are located at the top and bottom. This arrangement corresponds to the actual orientation of the machine's axes. The Y-axis keys are located in the top right and bottom right corners of the axis key grouping. For machines equipped with a rotary axis, it takes the label A and uses the keys in the opposite corners. Pressing any axis key, positive or negative, selects that axis for jogging in either direction using the handle jog wheel. Pressing and holding any axis key results in sustained motion of that axis using the increment or speed selected in the handle jog row in key group 3 until the key is released. For sustained motion without holding the key, the center of the grouping features a jog lock key, which can be pressed before any of the axis keys. After turned on, jog lock can be deactivated with another press. While this function is useful for simple machining operations, it is not recommended to leave unattended, and it is also not recommended to use jog lock in the Z direction. To the sides of the white axis selection keys are blue keys, used to control optional machine accessories such as a programmable coolant nozzle or chip auger. If the machine does not feature these attachments, these blue buttons serve no function. The next key is the tool release key. This is potentially the most dangerous key on the entire control panel. By default, pressing the key will immediately release the tool holder from the spindle, which can result in a broken tool, damaged part, and potential injury to the operator. It is highly recommended that this key never be used, and it can be disabled through the machine setting number 76. Instead of the tool release key on the control panel, operators should use the button located on the machine spindle housing to release the tool holder while holding it securely with the other hand. The final key in the function group is the Part 0 set key, which is used for setting a work offset such as G54. Pressing this key takes the current axis position in machine coordinates and places it into the selected register in the work offset table. During setup, it is often necessary to press this key twice, once for the x-axis and once for y. Different machinists and instructors have different methods for setting work offsets. Be sure to consult your instructor for the proper procedure to use in your lab. We have now completed our look into the Haas control panel. Let's review the 9 major groupings. Group 1, reset keys. Group 2, display mode keys. Group 3, operation mode keys. Group 4, numeric keys. Group 5, alpha keys. Group 6, cursor keys. Group 7, overrides. Group 8, jog keys. And Group 9, function keys. While there are many keys on the Haas control, by understanding their groupings and arrangement, with practice you can become proficient not only in locating the keys, but in operating the control.